Hello everyone. So we're gonna continue with chapter integumentary chapter in this, and we'll cover the accessory structures, which includes the glands. So there's a gland that makes oil, and that's called sebaceous gland. It's called sebaceous gland because it secretes something called sebum. It's called the sebum. Sebaceous gland secretes sebum, which is the oil, and it's mostly going to be coating the hair and epidermis. So it's basically kind of providing, it's going to be protected, and they release the sebum via holocrine secretion. So it protects your skin with the sebum, and this is the reason why during the winter time when you wash your hands a lot, it's dry out, your skin kind of gets all cracked and might be red, it might be infected because you wash off all the sebum, you wash off all the oils if you wash your hands too many times. So this is a type of secretion that's called holocrine secretion. I'm not really going into that, and in your textbook have all different shapes of these glands. Um, so I'm not going to ask you about those. Just know that this is a sebaceous gland that produces sebum. You need to know that sebum is what the sebum is associated with the sebaceous gland, and it's just going to put oil directly onto your skin, and it's to protect your skin. So the way that it releases oils is by having connected to a rector pili muscle that squeezes the gland and causes the hair to stand up. So if you were to pull on the sebaceous gland, you can also squeeze the oil out, and you can put the oil directly onto your skin, onto the surface of skin. Sebaceous follicles are large glands that connect directly with epidermal surface. So sebaceous follicle looks bigger, and this is a typical sebaceous gland. So this is what they look like under the microscope. If you're going to be given a slide of scalp, so on top of your head, that's the reason when you have a scalp slide, because you have lots of hairs, you look under the microscope, it's going to have a sebaceous gland here, and then you're going to see there's a empty space here. The empty space is where the hair was, so it fell out. So right next to the empty spaces, you're going to have the sebaceous gland, and that's going to be secreting oil. And if you squeeze the gland, and then it's going to cover the hair, and it's going to release some oil in the over to the hair, near the hair in this area. And this opening in the middle, where the hair got removed, it's called lumen. Sweat glands are so how are they different? Well, the sweat glands don't make oil. They make watery substance that we call sweat. And there are two kinds. There are apocrine sweat glands, and there are merocrine sweat glands, which is on the next slide. Apocrine gland is found in certain places only, and those places are going to be the armpit. The anatomical word for armpit is axilla, and around the nipples and the groin area. So these are going to secrete substance, sweat onto the hair follicles, and the chemicals here might contain fair amounts of pheromones. And so pheromones are like hormones, except that pheromones, they leave your body and they go to another person. So, or hormones, they stay in your body, and they basically are used to communicate, and one organ to next organ. But if you release the chemical outside of your body and it goes somewhere else, it changes the behavior of another person or animal, it's going to be called a pheromone. So in addition to sweat, some people they are going to give you they produce smelly sweat, and they have a BO. BO stands for body odor. you don't know what that means body odor. And it's not the sweat itself smells, the sweat has chemical in it, so there's all kinds of chemicals, maybe other things. Then bacteria eats those chemicals and eats the that causes so it eats those chemicals and it causes the body odor to occur. If you were having a relatively, if you have a relatively bad body odor, then you go to the doctor and the first thing they're going to tell you, well, you have to shower, use bacterial soap and get rid of the bacteria because that's what's causing the body odor to occur. So something that's really interesting about this is there are some people that do not have body odor or BO. And those people, they have this gene that's called ABCC11. I just searched the gene ABCC11 gene. It plays a role in body odor and earwax. So people that don't have a BO, they have this gene in their DNA, and it's found in East Asian people that have a ABCC11 gene. They don't have any body odor, and they have dry earwax, and it just happens to be the one of those coincidences that if you're one of those people who have ABCC11 gene, you can go and exercise all day, and you're not going to smell at all. And that's because you don't have the chemicals that cause the bacteria to eat it. And then there is another type of gland that's called merocrine gland. And they're also known as eccrine sweat glands. This is the old name, and you need to know both. So you need to know they're called merocrine or eccrine. Merocrine gland, they're found everywhere in the body. So remember, the apocrine glands, they were found in the axilla area, nipple area, and the groin area, but merocrine, they're found in axilla area, nipple, or the groin area, but they're also found in other places. So basically, the merocrine glands are found everywhere. Apocrine glands are only found in armpit, in groin, in the nipple area. So these glands produce watery sweat, and there is no chemicals in it to produce watery sweat, sensible perspiration, and then they are used for thermoregulation, excretion, and protection. So they're basically the ones that cool you down if you're, feeling really hot. So they have a secondary function. The secondary function is excretion. Excretion. And if you remember, excretion was for waste. If you have toxins in your body, then these merocrine glands will excrete it onto the surface of your skin, and that's going to be gotten rid of. So maybe you have experienced this before. Somebody who's been drinking all day, when they walk into the room, you can smell it. You're like, whoa, that person smells like a distillery. So it's not their breath. What it is, it's the excretion of broken down alcohol. It's going to go through their pores in the skin and then their sweat. And other places you might have smelled it is when you're sitting next to a very old person. The old person, it's kind of an old person smell, and it's because they have these American glands that are breaking down toxins, and that their organs can't break down anymore. So that's the smell you're smelling. If if you're sitting next to a really, really old person, where their glands are breaking down toxins. And this is what they look like under the microscope. So I will be asking you to identify both of them. So you have gotten yourself a merocrine gland, and this is what it looks like under the microscope. This is what apocrine gland looks like under the microscope. Apocrine gland, the circles are going to be larger, and merocrine glands, the circles are smaller, and apocrine glands, the lumen is big too. So this empty space here, it's called lumen, and it's going to be much smaller in the merocrine glands, and they kind of look clumpy. They clump together. So you should be able to identify both of these under the microscope. All right, so the other glands that we have are the mammary glands, and that's why we're called mammals, because all mammals have mammary glands. So if you go ahead and let's pretend that this is DNA, and there is this, we change color here. and there is this gene on this DNA that is responsible for apocrine gland. So what's really great about DNA is that you have replication. As long as you got one gene for merocrine or apocrine sweat gland, then you can replicate it, duplicate it, and so let's say you make an identical copy of it. You make another copy of it here. So you don't need to basically have two genes for apocrine gland. You can basically make another copy, or you can go ahead and mutate this gene. So here you had one gene and you can make a copy of it. Now you have two genes. You can go ahead and modify the gene, or not modify, mutate this gene. And once that mutation happens, it's not going to do the same thing as the apocrine gland anymore, but it's going to do something else. So what else can you do with it? Well, you can modify it to make milk. So mammary glands are modified apocrine sweat glands that are located in the breast, and they secrete milk. So apocrine glands are making milk now. Then there are hormones for reproduction, and those are the ones that stimulate production of milk in females. And also mechanical stimulation can do that. So breast also produces milk. And so one of the things that popped up, let me see, let me search it up for you. I don't know if you heard about it. Clear the drawings. It was there was a woman lactating milk from her armpit. So there was a mom who was breastfeeding, and she had milk coming out of her armpits. She noticed that. So breastfeeding mom noticed his baby hair soaking wet, realizing that the milk was coming from her armpit. So I think it was on the news. I was just trying to find that. Um, so the reason is because these glands are also located in the armpit area, nipple area, and the groin area. So it makes sense. So these apocrine glands might have been modified to produce milk. In addition, when you look at things like platypus, let me see. So platypus, if you Google platypus and milk, first thing that pops up is that do platypus sweat milk, basically. The reason it's asking that because um, they sweat milk onto the fur. So let me see if I can find an image. So yeah, they sweat milk onto the fur, and then their little ones. So the fur gets soaked with milk, and then their babies basically just suck the milk out of their fur. And this is the most primitive type of mammal. And then we have marsupials, which have nipples. And then we have placental mammals. So humans also have nipples. So this is a modification of apocrine gland to produce milk. Another modification of apocrine gland is earwax. So the fancy word for earwax is cerumen, however you want to say it. And depending on who you listen to, British people pronounce it saruman, I think. And then we pronounce it cerumen in the United States. That's earwax, produced by ceruminous glands, which are also modified apocrine sweat glands located in the external auditory canal. So that's area. Again, if you modify the apocrine gland and you have the gene for it, then it can do all kinds of stuff. In this case, it's going to be making cerumen, which is going to be earwax, and going back to people with the ABCC11 gene, they have dry earwax, so they don't have BO. Both of these are going to be associated with the apocrine glands because in the ear, they make dry ear bags, and then they also they don't have a BO, and it's modified ABC11 gene, or that's the gene that's causing it. So the function of cerumen is basically to protect your ear canal. It's basically to lubricate it so you don't have any damage there. If any, maybe an ant was to crawl in there, or a bug, it gets caught in there, so it's protected. Last thing we have is the accessory structure, which are the nails. Most vertebrates, they have, some of them have it, some of them don't have it. So some frogs, some amphibians don't have it, but most vertebrates, they have the nails growing. And this is found on the tip of your digits. And the word digits refers to your finger or fingers or toes. And singular digit would be finger. So just make sure you write that down, or you know what that means. So I want to make sure everybody knows from the very beginning what digit means. So these are some basic anatomical words that are going to be found in the textbook. So anyways, the nails are going to be found at the tip of your digits and toes, and their job is to basically have many functions. They're to protect your tips, and then they're used for digging, they're used for fighting, they're used for all kinds of stuff. And this worked as if you have, so the growth from the nail root happens from the epidermal fold towards the tip of the digit. So if you have this epidermis and it gets folded onto itself, then that's how the nail's gonna grow. Nails are gonna grow in this direction here. So that's what's happening here. So you have this epidermis. Let me change the color. You have this epidermis that's folded onto itself, and then you have the nail growing in this direction. So if the people who damage their nails, like a carpenter or something, they may hit their nail with a hammer a couple times, then their nail starts to grow in, all kind of wobbly and wonky, because just like the hair, this is the part of the nail that's alive, and then this is the part that's not alive. So if they hit their finger a lot from here, then it can damage the living part of the nail. So this is the living part, and this is a part that's not alive. It's made up of protein, keratin. So if you lost, if you lost your nail or pinky nail, but the root is fine, then as long as the root is fine, it's gonna start growing back just fine. Because as long as you didn't damage the root. And then we have this slide here. So this is just a zoomed in on the nail. You have the part that's alive, and then you have the part that's not alive. This fold of skin under the nail is called hyponechium. And then we have this last slide. So what happens to your skin as you get old? What happens is you have less pigment in the skin, so your skin gets lighter in color. You have fewer blood vessels, so as an old person is always going to be cold because they can't get blood to their skin because they have fewer blood vessels. If you get a cut, if an old person gets a cut, it takes really long time to heal. That's why your grandma or grandpa have that bandage on their hand like for a month. It's because they don't have a lot of blood supply uh, in that over there in the area, and then they also lose elasticity of the collagen fibers. So all collagen fibers and elastic fibers that are found in the skin, they go away. If you lose elasticity, you're going to get wrinkles, and that's the reason when someone has wrinkles, it's because they lost the collagen and elasticity in the skin. So that's I'm going to do it for chapter 4. And I know that this chapter was longer, the lecture was longer than the other ones, the previous ones, but we're starting to get into the normal length of each chapter. So the first 3 chapters were a little bit short. So sometimes we might even have to split the chapter in a couple of lectures. So I'll be going at this speed, but if you want to slow things down or speed them up, you can, you can do that with the videos. You can rewatch them, you can pause it, you can rewind it, you can forward it, whatever you like. But I'll see you in the next lecture. Or thank you guys for listening.